Hey, this is the video lesson for 6.5 on Algebra Properties. So today you're going to learn about three properties of algebra that are very important for the next couple years of your math. Now, just so you know, before we start, we want to talk about what properties are. So if you read here, it says properties are statements that are true for any number. So keep that in mind. When we talk about properties, they're just things that are always true for any number. So first off is the commutative property. The commutative property says when you add and subtract, the order of the two numbers doesn't matter. So for example, 7 plus 9 is 16, 9 plus 7 is 16. You can switch the order around. It also works for multiplication, 4 times 6 and 6 times 4. Now the associative property is a little different. It says the way in which three numbers are grouped when they are added or multiplied does not change. So usually you'll see associative property with parentheses. So here's what it says. If you add 3 plus 9 plus 4, 3 plus 9 plus 4, but you group them differently, you'll get the same answer. So let me show you. So if I do this, if I do what's in parentheses, 9 plus 4 is 13, 13 plus 3 is 16. Now if I solve the 3 plus 9 first, 3 plus 9 is 12, 12 plus 4 is 16. You'll get 16 no matter what. That also works for multiplication here. So 5 times 7, multiply that by 8, you'll get the same thing if you do the 8 times 5, multiply that by 7. So associative property does not matter how you group your numbers. And finally, we have the identity property. Now the identity property just says that any number plus 0 keeps its identity. 13 plus 0 is 13. In multiplication, any number times 1 keeps its identity. 7 times 1 is 7. Now, we're going to go down, we're going to go through the examples below, and we're going to use the properties to help understand. First off, just follow along with me here. Feel free to pause the video and write anything down that you need to do. So this one says determine whether the two expressions are equivalent. Now up here it says equivalent expressions are expressions that have the same value. So that just means they're equal to each other. Now, if they are equivalent, we're going to tell what property we used. Remember the three properties above. If not, we'll explain why. So I want to show you in one. We have 15 plus 5 plus 8, and the 5 plus 8 is in parentheses. Over here we have 15 plus 5 plus 8. Same numbers, but the 15 plus 5 are in parentheses. So without even solving it, I know they will be equivalent. So the first thing I would do would be to write yes. Now the property that is applied would be the associative property. The reason is, associative property says it doesn't matter how you group your numbers. You can group them the 5 plus 8 first or the 15 plus 5 first. You'll get the same answer. Now in example 2, we're going to take a look at it. It looks like associative property at first. We have 20 minus 12 minus 3 and 20 minus 12 minus 3, but the different numbers are grouped. But these would not be equivalent. And the reason it's no is because now we have to explain why the associative property, it looks like the associative property, but it doesn't work for subtraction. So I'm going to say the associative property does not work with subtraction. Okay, so that's all you're going to do here. You're going to, if they're equivalent, yes, what property? If they're not, why not? All right, now let's go on to the next. We have two more examples at top here. Same directions. Are they equivalent, yes or no? If yes, what property? If not, explain why. So let's look at 34 plus 0. So are 34 plus 0 and 34 equivalent? Well, the answer would be yes. Now here's how I know. It was the identity property. Now, remember what the identity property says. The identity property says, in addition, you can add any number to 0, or 0 to any number, and the number will stay the same. So 34 plus 0 will stay 34. Now, in number 4, let's check it out. So we have 20 divided by 5 and 5 divided by 20. Well, at first glance, it looks like, yeah, it's the commutative property. Remember we said we could switch the order of the numbers? But the answer would be no. And the reason is it's division. So we would say the commutative property does not work for division. Okay, so that's what you're going to do in A and B below. So let's take a look at them first. In A, you have to determine if this expression and this expression are equivalent. Remember, that's yes or no. If they are, what property? If not, explain why. And in B, are this expression and this expression equivalent? If yes, what property? If not, explain why. Okay, go ahead, see what you came up with. Restart the video when you're done. Okay, so let's see how you did. So I have my answers already written, and I just have them covered, so I'll show you what I got. So what'd you say for A? Well, first, when I look at it, I see it's 5 times 6 times 3, 5 times 6 times 3. The only difference is how the numbers are grouped. This has the 6 and the 3 grouped. This has the 5 and the 6 grouped. So, are they equivalent? Absolutely, they are equivalent. Now, what property says that you can group the numbers any way you want? That would be the associative property. So if you had that, give yourself a C. If not, pause it and fix it. Now in B, when I'm looking at this, when I first look at it, it looks like, oh yeah, I just switched the numbers. That's commutative property. But notice it is division. So in division, the commutative property doesn't work. So the answer is no. Commutative property does not work with division. Okay, so if you had it right, give yourself a C. If not, make sure you pause it and write the answer correctly. So now, let's go down and look at how you can use the properties to solve problems. This is where you actually have to apply it. So take a look at example 5. As I read it, I'm going to circle some things that are important. Are you ready? It says, in a recent season, the Kansas Jayhawks had 15 guards, 4 forwards, and 3 centers on their roster. So I'm going to highlight that there. 15 guards, 4 forwards, 3 centers on their roster. Okay. Now the problem says to write 2 equivalent expressions using the associative property that can be used to find the total number of players on their roster. Well, here's what I know. To find the total number of players, I just have to add up those numbers. So I just have to add up my 15 guards plus my 4 forwards plus my 3 centers. Now here's what's really important when you use the associative property. You don't want to switch the order of the numbers because that would make it commutative. So I have 15 plus 4 plus 3. Now I have the same exact numbers in the same exact order. Now to show the associative property, I have to group each expression differently. So in the first one, I'm going to group the 15 and the 4. And then the second one, I'm going to group the 4 and the 3. All right, now, last, to find the total number of players, I'm going to solve that. So in the first expression, 15 plus 4 is 19. 19 plus 3 is 22. In the second one, I have 4 plus 3 is 7. And guess what? 15 plus 7 is 22. All right, so that's how you do these. Now let's read C because you're going to be doing this one. This says, Brandy earned $7 babysitting and $12 cleaning out the garage. Now it says, write 2 equivalent expressions using the commutative property that can be used to find the total amount earned. Now, remember what commutative property means. You could look on the top of the page to the left in your book to remind you. So, write 2 equivalent expressions. It'd be something plus something using the commutative property. All right, pause it, write it, restart it when you're done. Go. Okay, let's see how you did. So first off, here's one expression. If she earns $7 babysitting and $12 cleaning out the garage, then I could do 7 plus 12, and that's $19, the total amount she earned, right? Now, to use the commutative property, I have to switch the order of my numbers. Oops, and I notice I have a little plus sign here I need to get rid of. That should be an equal sign to show they're equivalent. So over here, I'm just going to reverse the order. 12 plus 7, because the commutative property says that will get me the same answer, which it does. All right, so this should be what you have. If you had it, give yourself a C. If not, fix it as we go on to the page. All right, in example D, I want to show you how this problem will make your life easier if you understand some of the properties. So this says the area of a triangle can be found using the expression half times base times height. And we've done some work with that so far. Area is half times the base times the height, where B is the base and H is the height. Find the area of the triangle shown at the left. So take a look over at this lovely triangle right here, that slide. Now, I'm going to substitute my numbers in. So area is half times the base is 15 times the height is 12. Now, here is what the commutative property or the associative property allows me to do. In this problem, if I were to solve it mentally, because it's multiplication, I can order it in any number, or order it in any order, and I'll get the same answer. The thing is, I don't want to do half times 15 because 15 is an odd number. That's hard. The commutative property says I can do half times 12 times 15. And that's going to be much easier because half of 12 is pretty easy. That's 6. And 6 times 15 is 90. So the area of the triangle would be 90 square feet. Now, that was just an example of how I can use one of the properties, in this case the commutative, to switch the orders so I can solve nice numbers. You don't want to solve nasty numbers if you don't have to. So your job is to do problem D. Remember, you're just going to, well, let's read it first. D says, Vicky earns $6 an hour while working 11 hours over the weekend. So $6 an hour for each hour, and she worked 11 hours. She put 1/3 of what she earned in a savings account. Find out how much she put into her savings account. Well, I'm going to get the problem set up for you. So here's what we know. She earned $6 for 11 hours, which is 6 times 11. And she put 1/3 of that. So that's times 1/3. And that will tell us how much she put into her account. Now, your goal for this one is to use one of the properties to solve this, do it mentally, and solve it in an order that works for you. There's some numbers that are nice, there's some numbers that aren't. So pause the video, see how you solve it mentally, and restart it when you're done. Go. All right, so here's what I'm going to do. I'm going to use the commutative property to reorder this because I want to do, let me see. No, maybe I'll use the associative property here. We'll see. I'm going to do 1/3 times 6. So I'm going to do that first. So I guess I'll use a combination of the commutative and the associative property, and then I'm going to multiply that by the 11. And here's why I chose to do that. Because 1/3 times 6, or 1/3 of 6, is mental math. What's 6 divided by 3? It's 2, right? And I'm going to do 2 times 11, which is 22. So that was $22. Now, why is it easier to do that? Because doing 1/3 times 11 is going to get you a nasty number. And that number times 6 is nasty. You'll still get 22, but the properties allow you to rearrange these numbers so that you can do it mentally. Anyway, you're done with me. Thanks for watching. If you have any questions, make sure you ask me. And if you were absent, make sure you're doing the problems below that you are assigned. Thanks.